Good morning, everyone. Welcome to the lecture series on operating system KCS 401. Myself, Rekha Baghel, Assistant Professor, Ajay Kumar Garg, Engineering College, Ghaziabad. Today, we will discuss on the classical problems of process synchronization. So, in this lecture, we will going to discuss what are the various types of classical problems of process synchronization, like LeadersWriter, bounded buffer problem, sleeping power problem, dining philosopher problem. So, we will discuss all these problems one by one. So, first problem that we will discuss today is bounded buffer problem. So, bounded buffer problem is also known as producer-consumer problem. In this problem, there are two processes. One process is act like a producer and the second process act like a consumer. And one more thing, there is a buffer. Buffer means there is a buffer. We consider a buffer that can store n number of unit of data. So this is a buffer, and this buffer can store n number of data. So, there are two processes that are operating on the buffer, producer and consumer. So, producer and consumer, one process is producer, try to produce the data and store the data into the buffer, while consumer, other process is consumer. So, producer tries to insert the data and consumer tries to remove the data from the buffer. If the processes are run simultaneously, they will not produce the expected output. So, if we think about the main problems of bounded buffer problem or producer consumer problems, so three problems arises. First problem is when the producer tries to store the data or tries to insert the item to the buffer when buffer is already full. Second problem is when the buffer is already empty and consumer try to fetch the data from the buffer. And third problem is when producer and consumer both are trying to perform the operation on the buffer simultaneously. So, these are the three problems, and these problems are to be solved by using some algorithm. So solution for this problem is, the solution to this problem is creating three semaphore. Two semaphore is counting type and third semaphore is of a binary type. So, three semaphore are two semaphore are of counting and third semaphore is of a binary type. So, first semaphore is counting semaphore. We create two semaphore. One is full and second one is empty. So, what is the purpose of creating these two semaphores? Counting type. So, main purpose of these creating these two counting type semaphore is, first, full semaphore try to resolve the problem that the producer try to insert the data into the buffer when buffer is full. So, the purpose of this full semaphore is to resolve the problem of inputting the data into the buffer when buffer is full. So, the main motive of creating this empty semaphore. So main motive of creating this empty semaphore is the problem when the consumer try to fetch the data from the buffer when buffer is empty. So before fetching the data from the buffer, the consumer first satisfy the condition of empty semaphore. Okay, and next one, binary semaphore. Binary semaphore we are using for providing the condition of fulfilling the requirement of mutual exclusion. Mutual exclusion means here buffer is a common resource that will be shared among the producer and consumer. And if both are simultaneously try to access the buffer, then it can create a problem. So mutual exclusion is provided by the third semaphore, mutex. Mutex. And this is a binary semaphore. Binary semaphore. So we already know that in previous lectures, we already discussed that what is binary semaphore and what is counting semaphore. Binary semaphore is a variable which can store, which can work on two numbers 0 and 1. The value of binary semaphore can be 0 or 1, while the counting semaphore is a variable which can store n number of elements. Okay, its value can vary from 0 to n. N can be 10, 20, 50, and it can be any number. Okay, so solution to this problem is creating two counting semaphore, full and empty, to keep track of current number of full and empty buffers respectively. One binary semaphore, mutex, to keep track one process at a time, access the buffer. Producer produce a product and consumers consume the product, but both use of one of the container each time. Okay, so it's we just creating these three semaphore for fulfilling the or providing the solution to the producer consumer problem. So there are three problems. First problem is when the producer try to insert the data when the buffer is already full. Second condition is when the buffer is already empty and consumer is still trying to fetch the data from the buffer. And third problem is both are producer and consumer both are trying to access the common resource, that is a buffer. So these three semaphore provide the solution to these three problems. So if we talk about the structure of producer process, so we can just say that producer process work on empty semaphore, mutex semaphore, and full semaphore. So whenever a producer get entry into the critical section, or we can say get buffer, so it start producing the item. After producing the item, the first thing it will do, it will down the empty semaphore. Empty semaphore means initially we can consider that empty semaphore. Initially we consider that empty semaphore is, the value of empty semaphore is n. Okay, initially we consider that value of empty semaphore is n, and when the producer produce the item, when the producer produce the item, it will decrease the value of this empty semaphore. So its empty semaphore is n, and it will decrease the value. It will apply the weight operation and it will decrease the value of empty semaphore. And weight, mutex is binary semaphore, and the mutex value of mutex semaphore vary from 0 and 1. Initially, we consider that the value of mutex semaphore is 1. Initially, we consider that the value of mutex semaphore is value of mutex semaphore is 1. So we will just down the value of mutex semaphore, because the producer process get an entry into the critical section, so that a consumer will not try to will not enter into the critical section. So it will decrease the value of mutex semaphore by 1. So now the value of mutex semaphore is 0. So after adding the after producing the item, the producer will add next into the buffer item into the buffer. So it will, after completing the process, it will increase the value of mutex and increase the value of full. So it is important to note that what are the initial values of mutex, full and empty semaphore. We consider that initial value of mutex semaphore is initially 1, and the value of full semaphore is 0, and the value of empty semaphore is n. So these are the initial values, initial assumptions regarding these 3 semaphores. So this is the structure of producer process. Producer first try to enter into the critical section, or it is producer try to fetch the buffer after producing the item. So it is just first it will apply the wait operation into the empty on the empty semaphore. Next it will apply the wait operation. Wait operation is just like decreasing the value. Okay, so mutex it will apply wait operation, because after applying the wait operation on mutex, the initial value of mutex is 1, and after applying signal, it will increase the value 1. So now all other processes can enter into the critical section, or all consumer can fetch the buffer. So these operations we will perform on the on these semaphores. So next one is structure of the consumer process. So initially we consider that producer producing the data and insert into the buffer. So now there is an item into the buffer. Now consumer can start its process. So when a consumer process enter into the buffer, so first operation it will apply is wait operation on full. So now we have a information like that there is an item in buffer. So now the value of buffer is, we can say initially now the value of buffer will be decreased by 1, because consumer taking out the data from the buffer. So the total count of the buffer will be decreased by 1. So next operation that it will perform is wait on mutex, means it will apply the down operation on mutex. Mutex means mutex mutual exclusion, because consumer process have a access on buffer. So it will apply the restriction on the producer, so that producer cannot get into the buffer. So we will applying the mutual exclusion here. So when the consumer remove an item from the buffer, so after completing its operation, now consumer process just increase the value of mutex, so that all the operations, all the other variables apply the signal operation so that all the other processes or the producer can access the buffer and applying the signal operation on empty semaphore. Empty semaphore, initial value of empty semaphore, we just say that its empty semaphore initial value is 0. Now it will increased. So now we have just one item in the buffer. Okay? So it's one item in the buffer. So this is the process that will processed at the consumer end. So next problem is readers-writer problem. Readers-writer problem, in this case, in this readers-writer problem, there are n number of processes, and some process want to share some process want to read the data from the shared resource. This resource can be a file. Suppose this resource can be a file. Okay, this resource can be a file. From this file, some processes want to read. Some processes want to read data, and while other processes want to update or perform read-write operation on this file. So the processes, those want to read data from this file, are known as a reader, while the other processes that want to update or want to write something on this file are known as writers process. So in this problem, there are two types of processes. One process is considered as a reader, and while the other process is considered as a writer. Okay, so reader process can only read the data from the file, and writer process can read as well as write on the file. So, and some of these processes may want only to read the database, whereas others may want to update or to read and write the database. So, precisely on operating system, we call this situation as the readers-writers problem. So, main problem parameters of this problem are: one set of data is shared among a number of processes. Once a writer is ready, it performs its write operation. Only one writer at a time is allowed to perform write operation on the file. If a process is writing, no other process can read it. If at least one reader is reading, no other process can write. Reader may not write, only read. So we can summarize all these points in one table, like these are the two processes. Suppose these are the process P1 and P2, and outcome. Okay, we can say what is the result. If first process want to read and second process also want to read the file, then it is allowed or not allowed. Okay, if two processes are readers only, reader type, then both the processes are allowed to access the data and read operation will perform simultaneously. Suppose first process is read. First process is, reader. Okay. So first process is read and second process is of write. second process is of write type, is of writer. Then one process is of reader type and second process is of writer type. Means first process want to read the data and second process want to write the data. Then it is allowed or not? Not allowed. We already say that if one process is reading, then no other process is allowed to write on the file. So if first process is of writer type and second process is of read type, then it is also not allowed. If one process is of writer, second process is of writer type, then it is also not allowed. It is not allowed. Okay, it is also not allowed. So this is the basic. Yes. So what is the problem of LeadersWriter? So main problem of LeadersWriter is when one process is performing read operation, then no other operation is allowed to perform write operation. If one process is perform writer operation, then no other process is allowed to perform the write operation. So we just if okay, and last is if one process is performing read operation, then other processes are allowed to perform read operation. So there are several variations of how readers and writers are considered. All involve some form of priorities. So what are these priorities? First is shared data, second one is data set, and third one is here we are using the semaphore for resolving the problem of LeadersWriter. So first semaphore is RW read write mutex. Second one is semaphore mutex initialize to 1. So main problem of our is to apply the restrictions to the writers so that writer will not access the file when reader is read operation is performing. So for this purpose we are using the one semaphore RW read write mutex. Okay, read write mutex, and second one is mutex. So mutex is we already discussed that mutex semaphore apply the mutual exclusion. Mutual exclusion when the reader is performing the operation, then writer will not access the file. So it will apply the mutual exclusion. So next one is one variable we are taking read count. So initially the value of read count is 0. Read count specifies the total number of readers those are reading the file. So it will increase when the number of processes of reader type enter into the critical section. So these are the main problems of so we will discuss about the structure of writer. So here we are using the one semaphore RW LeadersWriter mutex, and when the writing operation is performed, it will increase the value of this mutex. Okay, this is the writer operation, means when one single writer type process enter into the critical section, it will down the value of RW mutex. After performing the writing operation, it will increase the value of RW mutex. Okay, so this is the reader process, structure of reader process. Here, whenever the reader get an entry into the critical section, it will down the mutex and increase the read count. Okay, if read count is equal to 1, then it will decrease the value of RW mutex, so no other writer type process get enter into the critical section. Okay. So after performing when the reading process is performed, it will increase the value of mutex. Now if another process is coming for reading, it will decrease the value of mutex, and it will perform read count. Okay, it will perform read, and if one process completing the reader process, so it will decrease the value of read count. So if read count is equal to 0, it means no reader type process is performing the read operation on the buffer. So now if any process that want to perform write operation on the buffer on the file, so it will allow to use the buffer. So this is the main concept of LeadersWriter problem. So next problem we will discuss in further lectures. Thank you.